Okay, welcome to the Advanced Software Engineering video lecture number 1, and now we are going to talk about Scrum to get started with the concrete agile method. This is Antero Järvi and my name is Tuomas Mäkilä.
Hi everybody.
Before we start the actual content, I must mention that these slides are based on the work by Henrik Nyberg and Mike Gone, and we are using their material as base for our own lecture slides.
And they were under a Creative Commons license, so we really can use them.
Yes.
Okay, let's start with the big picture of the whole space of agile methods. So they are not born in a vacuum, but based on some kind of principles that we don't talk about today that much. But there's agile movement, lean movement, even things like chaos theory, game theory, philosophy, and research on all of these. And these are not applied as such. In order to be able to apply all of these principles, they have to be somehow made into tools.
Yeah.
Which is here in the middle of the slide as practices. Scrum, which is the topic today and the most widely used in industry, and then some historical notes, Extreme Programming, XP, which was the first such productization of these principles into something that can be actually used. These never work if you take them just out of the box from if you buy a Scrum book and start implementing it. It never works. So in every company the situation is different, and in every company, in every project, the situation is different in terms of things like what kind of customers you are working, what kind of how difficult the project is in terms of how uncertain user requirements you have, how uncertain technical things you have, what kind of people you have, how experienced people you have. So all of these change.
So you basically have to find your own way to use these tools.
Yes.
And in this lecture we are going to concentrate on this Scrum practice level, and as Antero mentioned, we are coming back to these agile principles in following video lectures.
Yeah, and I just want to add that the reason why we need to also address these principles is that they give you the guideline on how to take out of the box Scrum and apply it to a certain context in a certain project.
Yeah.
You have to understand why it works to do it.
But in order to understand it as these agile principles, it's better to start with this concrete practice first and then go to these more abstract principles. So Scrum in a nutshell.
Yeah, one way of briefly understanding what Scrum tries to achieve or does achieve is that it basically splits everything into small pieces. So if you look at the slide there, you have in the one corner you have split your organization, which means that Scrum always uses pretty small teams. Something around 7 is the maximum that really works. So it's an intimate small team. You, of course, if you look at that time scale, in there you split the work into iterations. This is something you of course do even if you wouldn't be using Scrum. So this is an iterative method. You split your time. Try to achieve small piece at a time and grow the product in every iteration. But then you also split your business value, and this is something you don't do in every method. But in Scrum, it's very important that so business value means basically it means requirements, which are expressed in Scrum in terms of a product backlog, which contains not all requirements but those that you have discovered, and those are also prioritized so that the most valuable ones that should be implemented first are on the top. So that's what we mean by optimizing business value. You always know which are the most valuable ones to implement next.
Yeah. So the Scrum doesn't see the software as a monolithic entity, but rather as this kind of incrementally built kind of, how to say it, compilation of building blocks.
Yes, and there are a couple of important things also here in this slide. So if you look at this, split your product and optimize business value. So both requirements and the ready product, they are in small pieces or sliced in small pieces. Not all of this is known or discovered in the beginning of the project. The whole idea is that you discover some of it and start working on it. And while you do it, you learn more about the problem you are solving, the need of the customer, and also the solution, the technical things, and how it should be implemented.
Yeah. So we are ready for changing requirements.
Yes.
So to speak.
And right in the middle, there's somebody optimizing the process, which is many really experienced Scrum practitioners say that this is the only one you never can throw away. Yeah, everything else in Scrum is like optional. You can modify things the way you want, but you can't do this because this ensures that you will, like in the previous slide, there was the idea that you always have to fit the Scrum into an organization, into company, and into a project. So this is something you need to do when you start working in a new project. The Scrum isn't a perfect fit in the beginning. Yeah. But as you work, you optimize it and you make the fit better.
And the key point here is that in Scrum there are these clear practices how to improve the process itself.
Yeah, it's like you need to do some coding and you need to do some optimization. And then there's even a guy called Scrum Master who makes sure that you do it.
But we come back to that later.
Yes.
So the background behind the Scrum.
Basically, why something like this was needed. IT projects are or have been really, really famous for failing. This is some pretty old data, but old data is needed now because this is the era before Agile. So there's I don't know, is this a consultancy company or something, Standish Group?
Yeah, I think so.
It's been doing a consistent job of tracking how IT projects succeed for more than 20 years now. And roughly 20 years ago, the average succeed rate was merely 15%. Succeed means that the project is completed on time, in budget, and it delivers what was intended to.
Yeah.
So that's 1 out of 8 projects. And if you compare it to any other field like building houses or something.
Or bridges.
Yeah, or whatever.
Yeah. Of course, we have one failure near us, but let's not go into that.
And year 2004, it's the last year when Agile was it was a marginal way of doing things back then. So this is how far we got in terms of succeeding.
Yeah. And I think the key here is that even before the Agile become kind of mainstream methodology, the things were going to the right direction.
Yeah, for several reasons. Before this video, we discussed briefly what were those reasons and disagreed a bit.
Yeah.
But my opinion is that object orientation is one of the biggest reasons, because it really, if you think of how requirement work is done and how requirements are expressed and how then the technical design is expressed. So object orientation was the first paradigm that used the same concepts, the same way of organizing things here. So it really eases up communication between business analysts and engineers.
Yeah, remember this idea because in the next slide there are a few other reasons.
Yeah, but don't go there yet.
Okay.
There's this pie diagram with a couple of slices.
Yeah.
So the biggest reason why things failed back then was that when the system was delivered, most of the things it contained, most of the features, most of the functions were things that were not needed. Yeah. So as you see here, this is a statistics of systems that have been put into use, and roughly 2/3 of everything that has been implemented is something that really isn't needed. So you can think about the reasons for this. We'll come back to it later.
Yeah. Of course, there were hints towards this idea in the previous slide. So we were talking about optimizing the business value.
Yes.
This is directly connected to that idea. Yes. And we were talking about accepting the changes in requirements. And this is also something that is connected to this by that.
Yeah.
We basically shouldn't do features that are never used.
That is like stupid.
Yeah. Okay, then to the reasons for why the things get better even before the agile. You mentioned that object-oriented paradigm was one reason. There are a couple of other reasons here.
And these reasons are by the Standish Group consultants. So this is their view, which is obviously our view is better. But these are the guys who did the research. So let's see what they have. So the top 5 reasons for success. Number 1, user involvement, meaning that the user. So it used to be in a way that the only place where the user or the client was involved was in the beginning of the project, when we tried to somehow interview, run whatever requirement workshops with the customer, and try to understand his or her needs and capture all of that into a huge requirements document. Yeah. The problem there is that there's no way that any customer could understand what he or she needs before she gets some idea, some trials of the software that's being built, because the problems that are solved with the software, typically they are complex and dynamic and really difficult to understand and grasp.
And we are usually talking about new kinds of tools. So if you don't know what you are looking after, it's really difficult to kind of say definite things about that.
Yeah, so this is something that maybe the first thing that you should remember from this course. Customer doesn't know what he or she needs in the beginning of the project. Yeah. That is normally a fact.
And usually developers do not know either, so it's kind of fair play there.
So customer is always right, doesn't hold in software projects.
I think the executive management support, clear business objectives, optimizing scope, they are all related to the phenomena that the software became kind of important issue in companies. Mm-hmm. In the 90s, it was something that the backroom nerds were doing. And when we come to the 2004, the things had changed, and companies saw that business is important part of their operations.
Yeah. So, for instance, this executive management support in the late 1990s, we started seeing the role of chief information officer in the executive group of companies. So it became a strategic thing. So more support and clear business objectives. Is that also related to?
Yeah, I think so. That software is connected to the business objective at all.
Yeah. And optimizing scope, it really means that once you are running the project and the project starts getting late, which normally happens, 15 to 30% of all the projects were late or over budget. So then you are not just pressing harder and harder, but you start discussing that, okay, do we really need all of this project? Yeah, or could we reduce the scope and keep the date and keep the budget, which is really a wise thing to do. Yeah. Because let's get back really briefly here. If you see that something like 45 to 2/3 of the features are not needed. So probably when you are doing optimizing scope, you are in the late phases of the project. Probably you have learned something and you can already identify that maybe we don't need all of this. Yeah. But it has been difficult because then most of these projects back then, and still some projects, they are bought in a way that you sign off a contract that states that all of these requirements need to be implemented, and then there's a penalty or fine if something is missing.
You basically know the end results before you start.
Or you think you know the end results, and then all the stakeholders are like they are stuck with this. And if you want to change something, then you need to go and talk with the lawyers and
it's
this,
probably not the correct way to do it.
So one reason also is stupid way of buying systems for these many failures.
And it can be found behind these reasons if we turn the upside down. Of course, in 2004 there is already agile processes mentioned there, although the agile wasn't mainstream at the time.
But in some of these projects they were used in agile way, and this improves the whole number to 34. Okay. And then there's also, just note, those average cost and time overruns. So we are not talking about small failures. So 170% cost overrun means almost 3 times the cost that was anticipated.
Yeah.
And that also has gone down.
Okay, a few words about Scrum history.
Where this whole thing came from. There's a guy called Jeff Sutherland. Let's see if I can get here. This one, he is normally, everybody thinks that he is the inventor of Scrum, and in some sense he is, because at least he is the one who created the first implementation of Scrum in a software project in Easel Corporation.
Yeah.
And then I have no idea what happened or how he worked together with Ken Schwaber. But Ken Schwaber is the guy who started to popularize Scrum and evangelizing about it.
Made it into a product.
Yeah, made it really into a product. And then 2001, and there was the first Scrum cookbook that really sold well, and this is what started bringing Scrum and Agile into the mainstream.
Yeah, I think the one key thing here is that the work for Scrum and Agile methods in software engineering started very early in the 90s, even in 80s, and it took quite long time to kind of build these usable practices that could be adopted in companies everywhere.
And one point here to note is that these guys, Jeff Sutherland, Ken Schwaber, and there are many others who have been working with this before 2001. Basically, all of them are practitioners. So this arose from the needs from the people who were actually struggling with their products. So this is not an academic thing.
And that's actually one point, that if someone tries to say that this is kind of scientifically proven, he is probably lying, because there hasn't been any really extensive scientific work behind these ideas.
No, but at this Jeff Sutherland has said or written that he used science as a tool or as a backup. For instance, evolutionary biology, complex adaptive systems, and things that you would think that have nothing to do with software.
Yeah.
Okay, but they do, because if you think, we'll get back to these issues, but if you think of a bunch of people, like 5-7 developers working with something that's totally uncertain and very unlinear, not simple, not predictable, that's a complex and adaptive system. Yeah. And there has been science in there on how these kind of systems should be addressed.
Yeah. So the Sutherland basically used scientific theories to build the Scrum methodology.
And don't change that one yet, because then there's one paper here, the new product development game by Takeuchi and somebody else.
Yeah.
And it's on the business management science paper. And Jeff Sutherland claims that he didn't know about it. But yet, what's described in that paper is exactly the overall structure and many of the principles of Scrum, and they even use the word Scrum in there. So, okay.
Maybe he has saw the paper at some point.
Yeah, but again here, it's really interesting and really common that somebody in the academic world has done really valuable work, and then it just sits there, nobody reads it.
Yeah, yeah.
So if you think of 1986, it took 20 years before the Scrum made mainstream in software.
So you need these kind of champions that push the ideas to the industry.
Yeah.
Okay, this is a slide that tries to say that nowadays the Scrum is used for basically everything.
Yes. This is not like self-evident, because when Agile movement started with extreme programming was also maybe invented or at least popularized by Kent Beck, am I right?
Yes.
And then Kent Beck said that XP works if you have a maximum team of 5, you have clear requirements, you are not working on any business critical issue, and the team is led by Kent Beck. So this is sort of a sweet spot of Agile, this kind of a situation where Agile really, really works well. But the point is that everything else also works well in this kind of situation. But in the beginning of our Agile era, there was a lot of criticism that we can never apply this kind of a non-structured method which doesn't really create that much of documentation and anything on real software projects that are difficult and large and critical. But if you look at least there are like FDA approved life critical systems, satellite control software. You have been working on Agile in space software,
space related software and hardware.
Yeah.
So there are multiple kind of really mission critical things that you are doing nowadays with the Scrum, and we probably get back to this, but I want to mention at this point that it's kind of myth that these Agile methods are kind of relaxed hippies way of work compared to these quality systems, which are very strict and serious. It's quite opposite, because the Scrum, especially XP, they are very strict. They define these ceremonies that you have to follow, and they are quite laborious for software developers to follow.
They are strict in terms of issues like how you cooperate, how you work together, but they are totally flexible on issues on how you build the system.
Yeah,
and this is the essential thing. So
they dictate your daily work very very detailed manner, but don't kind of dictate how you should do the overall system development.
Okay, let's go forward.
Okay, the Scrum is called Scrum because
that it's the Hirotaka Takeuchi and Ikujiro Nonaka. Now I get to remember the names because I can read them from there. They explained that this was an article about how product development should be done. So not software development, but product development when it's hard to predict, non-linear and difficult. So they said that the relay race approach is conflicting with goals of maximum speed and flexibility. So it's a little bit different than what we try to achieve in Scrum, but it's as opposed to what normally product development tried to do, which was to cut costs and deliver something that you can predict early on time. So the way product development was organized was typically by trying to be as predictive as certain that okay, we can deliver these and these things 2 years from now, and with this amount of a budget with these people.
But it kind of assumes that there are no external pressure. And in Scrum, the idea is that there is...
and everything will anyway change during the project, including what we want to build.
So the creators of Scrum, they see software development somehow as a game of rugby that people are really pushing into each other.
Instead of being like able to predict when things will be ready and what it's going to cost, more important things are just making headway as fast as you can, so maximum speed, and then flexibility. So being able to adapt as you learn about the project in hand. And this Scrum, that formation is Scrum. It's the Australian rugby, and they start in that way that the teams like lean against each other, and then the ball is thrown in there. And there are several stories on how this relates to Scrum. Let's not go.
We can have another video lecture about it.
Or you can Google about it.
Maybe that's better option. So there are pillars of Scrum. So these try to define the essential kind of philosophy behind the Scrum. Yeah.
So things that you need to have somehow. If you want to implement Scrum, you have to somehow implement these issues. First pillar is inspect and adapt, and it means that in many levels in Scrum, you are always in a mode of like really trying to see and understand what's going on, and then adapting accordingly. And this, of course, this holds for the product you are building. So there are. This is implemented by feedback loops almost always. So you have feedback loops, for instance, for learning about the customer's need, what needs to be built, and then adapting on what you build, and also on your internal, like how you work together in Scrum. You inspect it every now and then. You discuss things that work, things that don't work, and then you change how you implement Scrum. So this is some pillar that you need to have on many levels.
And I think you have to keep this pillar in mind, because it will really open up to you when you see the actual practices of the Scrum in the later in this lecture and in next video lecture.
Then you have a prioritized. How do you spell that?
Something like that.
Product backlog. Product backlog was the place where all the user needs or requirements in Scrum, they are most often talk about user stories. So they are there in the product backlog. It's a list, but it's a prioritized list. So that in any phase in the project, we always know which ones are the most important that the customer knows that he or she needs. So
again, focusing on the business value.
And this is the most important tool for not building those 2/3 of the requirements that nobody eventually needs. So whatever you build, you already then always know that this is needed. Time-boxed incremental delivery. So this means iteration, but incremental means that it's not iterations to refine something, but to increase something. So you're always
building blocks.
Adding something more. And the word delivery also means that you need to deliver it to the customer. So it's not just let's take these 3 user stories and implement them. Let's take the next 5 and implement them. You always need to deliver it in the hands of customer.
In order to get feedback. It's somehow related to the inspect also.
Cross-functional self-organizing teams. Cross-functional means that in a team you need to have all the skills you need. You need to have somebody or everybody who knows how to test things, somebody or everybody who knows how to code and so on. And somebody needs to understand the customer, at least be able to talk with the customer so that you can discuss about the features. So all the skills you need in there. In practice, however, you also have often external team members. So there are like special things like in related to systems architecture or things that you need only in some phase of the project.
Special skills.
So that it doesn't mean that you don't use anything else, but this is the core team where you have everything you need in a daily basis. You need to have it there. And then transparency and communication, which means that whatever the team does, everybody needs to easily understand what everybody is working on. Everybody needs to easily and constantly know if somebody has problems, if somebody needs help, how to work gets coordinated and so on. And there are also practices for this in Scrum.
Yeah.
So because of this is not based on, so how the project proceeds or progresses is not based on any plans that are followed, then this is like the other way of doing it. Seeing what we have at the moment, being transparent about everything we create, everything we need, and communicating really fluently and constantly.
Yeah, and in practice we use kind of version control tools here. We use super simple project management tools like whiteboards with post-it stickers, and then we utilize face-to-face discussions and meetings.
Yes.
One thing is self-organizing. It's something that you missed, and I think it's very important here that we in Scrum we don't have this kind of managers or bosses, but the idea is that the whole team takes the responsibility, and it's if it works, it's really efficient, but it's quite hard to implement and understand.
A self-organizing team takes time before everybody learns his own role and how to work with everybody else.
It's not anarchy where no one takes responsibility, but it's about everyone taking the responsibility, and it's something that doesn't really happen in society in general, so it's a little bit new concept.
And as you said, there are no bosses, so it means that nobody from outside of the team can like lead what happens inside the team. But within the team there is leadership, and in a good agile team there are many leaders depending on the issue that's at stake. So somebody can lead the design, somebody can lead the testing, somebody can lead whatever needs. So whoever is best in that takes the lead.
Yes. Okay, this is basically the pillars in this kind of list form. So there are lots of same things that in previous slide. Transparency, we talked about strict prioritization, we talked about that also. Empirical adaptive, there are some more detailed issues here.
So this is the inspect and adapt point. Slightly. Yesterday's weather is maybe something that you don't understand what it means. It means
I
that
don't understand.
You don't understand. Okay, it's the best way of estimating. So is to today's weather is to, or tomorrow's weather is to guess that it's the same than today. And because normally weather systems they take several days to pass. So this holds also for your estimation. So if you don't know how something's gonna go tomorrow, just assume that it is not going to change.
It seems to be raining today, so probably tomorrow it will be raining.
This time
also.
I know it's not gonna rain. But
let's see.
Okay, and then continuous improvement. There I'd like to point out that so this is the like adaptation of the way you work. And there the word improvement is not the best one. So it should be continuous adaptation. It's not like you are making your process better, but you're more fit.
Suitable, yes, for the situation.
And
this is something that in Scrum we have these two levels, that we are building the software and we are trying to adapt to the external situation. But at the same time we are trying to fine-tune our actual method of working.
Yes. And there's one thing that we didn't have in the previous slide, which is pull scheduling. Team chooses how much work to commit to. So it goes in a way that the customer, or there's a guy called product owner, we'll talk more about that later, prioritizes what are the most important features or user stories, but then the team chooses how much of that they take for the next iteration. And this is because the team is the best expert on understanding how much work they can crunch. So this really means that there's no boss from outside who can say that, okay, this is getting late, so you need to take something more. It's not going to happen, or it shouldn't be happening. It happens in practice sometimes, which is a bad thing.
About time boxing in face-to-face communication and simple tools we already discussed.
Not the simple tools, but let's not discuss.
Okay, so here we have picture of a Scrum sprint. So Scrum is organized in these increments, in these iterations, and they are called sprints. And this tries to tell us how the kind of normal sprint goes.
Yeah, it's a little bit more detailed, not that detailed yet, but a sprint, in this case, it's 3 weeks. It's a bit long for what most projects use, from 1 to 2 weeks typically. But it starts in the beginning. There's here a sprint planning meeting, which is very typically takes a whole day. And there are 2 things happening in there. First is the product backlog prioritization.
Yeah.
So with the customer, the team discusses the features, what should be taken in the last in the next iteration. So it's prioritization, discussing, making sure that the team understands what these features mean. So because we don't have any excessive requirements documents, we have just simple user stories which can be 1 or 2 lines for a feature. So there's like discussion, and then also in the sprint planning, design, so technical design gets done to understand how much work there is.
Yeah.
And based on these, the team makes the commitment to a certain amount of high priority things from the product backlog. And this is what kicks off a sprint.
Yeah.
And then the sprint goes on. Normally, here in the corner, you have a sprint board, an example, which is just in the whiteboard.
It's the simple tool.
In fact, no, this is not the sprint blackboard. This is for the retrospective. So
okay, yeah.
Couldn't read from a small. So this one here is even more difficult to read because we can't use PowerPoint in this video thing set to us.
What's the
so
PowerPoint?
It needs to be a PDF, and in making this PDF, everything, these small yellow things here, they are supposed to be readable. They are not.
Well, but we basically take the user stories from the product backlog and
that were chosen for the sprint.
Yeah, and then we elaborate them further, add some estimation.
Yeah, and basically turn those are like user need facing things. The user stories, they describe the needs, so we create technical development tasks out of them. And then with this board, during the whole sprint, we track how they get done. So this is the visual board where we see what all the work that needs to be done, and then who is working on what is the phase of it, and so on. So if it's a happy sprint, then in the end, all the work has passed from the left to the right, and everything is done.
Yeah.
If not, then there are ways to deal with it. Okay, and then every day there's a practice called Daily Scrum, which is made for communication of between the team members. The overall goal there is to make sure that everybody understands what everybody is working on, understand or see if there are conflicts, if there are dependencies between everybody's work. So it's like a coordination meeting, and it's not a long one, it's something like 15 minutes. Very briefly, just check the situation. But it's mandatory that it happens every day, typically in the morning.
Yeah.
And then the sprint goes on, and in the end, there are 2 things that need to happen, or in fact 3. The important thing is that we release something, so we deliver something for the customer. A workable piece of software where the customer gets first-hand feedback about those features, those user stories that were implemented, and that way can understand better his or her need. And then there's a the demo session is for this purpose. So in the demo session, the customer participates and the team explains the new piece of software or new functionality, and it's also done in a way that it's not shipped just to the customer, but everybody's there, so that there's a discussion to help the team to understand.
And get the feedback basically.
Yeah. And then the other one is a retrospective, which is then teams internal meeting for discussing things that, okay, in this iteration or in this sprint, how did things go?
Yeah.
Did we work well? Is there something we need to change in the way we work?
Yeah. Maybe we do the backlog in a different way in the next sprint. Maybe we don't have the daily scrums. We have only every other day. There might be changes like
or
that.
Maybe the project is getting technically a bit different than we thought, and we need to get somebody else on board who knows something we need. So anything that needs to be discussed, anything that can be improved is discussed there. And then there's a principle. So in the first slide today were these agile principles. So they are pretty concrete things. So for instance, principle number 8. Later on, we'll explain where this numbering comes from. Yeah. It says that agile processes promote sustainable development. The sponsors, developers, and users should be able to maintain a constant pace indefinitely. Yeah. So this is the reason, or one of the reasons, why the team chooses or commits on how much work we'll be doing. Yeah. So that people don't get burned out. Yeah. Maybe the second thing that you need to, the first one was something that customer doesn't know what he or she wants. Maybe the second thing you might really remember from here is that in software project, the most important tool is the developer. So you want to keep that tool in shape. Yeah, yeah. So this is, in my opinion, this principle 8 is the most important agile principle. And besides, in today's work environment, if you burn somebody out or try to stress him or her, you lose that work.
Yeah.
For other companies.
That person back. Maybe he even changed to other discipline.
But anyway, to other company.
Extreme cases. Okay, here's the same picture basically in a little bit simple and stylized format. So there are the key elements except the sprint planning review and retrospective.
Yeah. But the overall Scrum, if you want to call it a process structure, it's really simple, as you see. This is all there is.
Yeah, these are maybe the kind of key work products they are. So we simply have the product backlog that is elaborated in the sprint backlog. And based on the sprint backlog, we are doing the new increment from actual working software. And that's it.
Yeah. And the green arrows, they're 2 to 4 weeks. I would say that most often 1 to 2 weeks. That is the feedback loop for the customer to help him or her understand better what he needs.
Yeah, 2 to 4 weeks.
Yeah, and then this 24 hours is the feedback loop for the Scrum team, so to understand how to coordinate the actual development work.
Yeah.
Okay, this is probably really self-evident, but since there are still people who talk about waterfall type of development where there are terms like requirements work, design work, coding work, testing work.
In individual phases.
In individual phases, so that first requirements is done, then design, then coding, then testing. So all of this needs to be done also in agile projects.
Yeah,
all of this happens, but it happens at the same time.
Yeah.
So, of course, the picture in there is in the bottom. It's from this Takeuchi's article, and it illustrates that this is one sprint. So in the beginning of the sprint, there is a bit more requirements work than in the end of the sprint, and so on. And of course, in the end of the sprint, there's a bit more testing work than in the beginning, but still, most of it is done every day.
Yeah.
And this is also, if you relate this to the cross-functional team. So everybody
has to be able to work in that environment.
Yeah. And you might have specialties. Somebody is specialist on testing, and still he or she has something to do every day.
Okay, the last slide of this lecture. Maybe we have already talked about this, that the sprint, the iteration is time boxed. And one idea of time boxing is that we don't allow any changes to the requirements, to the backlog during that time period. So we have the middle point when we change from iteration to another, and then we can make modifications, even big ones. But during the sprint, we concentrate on the development work.
Yes, and it's very important, because if you think of the development work, like the daily Scrum meetings during the sprint, what you do there is you coordinate your development work. You are discussing really detailed software design issues, implementation issues, things like this, how they relate to each other. Is there dependency to some API? Is some API stable? Can I trust on that? Things like this. So you really don't want to have like new user stories in the middle in there to be efficient. And the sprint duration, which I tended to during these slides always take a bit shorter, 1 to 3 weeks. The rule is that make it as long as you can. So how long can you keep the change out? This is your rule. And why you want to have it a longer one is that the sprint planning and sprint retrospective, those are extra work, a couple of days of extra work. So if you have 1 week length, then you are using 20 to 30% of your time in these ceremonies, and not actual coding.
Okay, so this was for our first video lecture. We went through
it was my first. Thomas has been doing this in other courses.
But now you have some kind of understanding what the Scrum is, and we actually talked a little bit about agile principles, although we promised we won't go into that until the next lecture. But that was it. So thank you for your attention.
Thank you.